the screen. So in this case, for example, 8A, there'll be two numbers, one below the other. They are 13.5 and 13. So the output you show for 8A, the output, it says to show the output. So you would write only this as answer, 13.5, and a 13 underneath it. This will be your answer. Don't write anything else, only what you expect to see on the screen. Any question? Anything I should go over among these? Number 8, 10, and 12. I'll go over 10. Several students had wrong answers there, so I'm going to go over to 10. If you want me to go over anything else, ask for that. Okay, problem 10, first part says, part A says, write statements to square the content of the variable x and to write it on the screen. Now, if it says just square the content of the variable x, if it says only that, that means you're replacing the value of x with the square of the original value. So to do that, this is the statement. It's x multiplied by x, and you put it back in x. Only then you're squaring the original value of x. So the new value, x times x, should replace x. So this will be the answer to that. If it says just replace value of x with the square of the original value. But in this case, it says print it also. So that means after doing this, you can say cout x. So these two statements together will be your answer. Now, actually, for this question, another way to answer is we don't really need those two statements because it says just print the square of the value of the x. So you can just say cout x times x, because you're just printing the value, the square of the value of x. So this will be correct also. Part B says to store the character s. For that, you need to declare a variable as char type. So char x equal to s in quotes. If you miss the quotes, it'll be wrong. If you miss the quotes, then it'll try to interpret s as a variable, but you don't have a declaration of s, so it'll complain that s was not declared as a variable. The error message may not correspond to what the mistake is. The mistake is missing quotes. Okay, part C says to replace the value of the variable d with the decimal part of its current value. Okay, one way to do that is to declare another variable as int type a and copy the d in it. So now a has the integer part of it, part of the d. So if d has 35.682, then a has 35 now. So from d, if I subtract the a, that'll be fractional part, just the 0.682. So if I put that in d, then I'm replacing the value of d with a fractional part of the original value. So this will be correct. Instead, I can do it in one step like this. D equal to d minus int d. Because we learned in the last class that int operator will give you integer part of d, integer part of the value of d. And if I subtract that from d, then that will be the fractional part. Put that back in d and you're done. So this is alternate way to do that. They're both correct answers. There are more than one way to do anything. Any other question from assignment 5? Let me go over the number 12 also, and then we'll be done. So number 12, I need to go over quickly because some of you didn't have the decimal points, I gave you the credit. I didn't penalize you this time. But if you miss the decimal point, that's not quite a right answer. I explained to you many times that in computer science, the decimal point matters. So in number 12, it says, write the values that are stored in S, J, and K. So let's look at S first. S is equal to 3 over I multiplied by 3. Okay, so the 3 over I means 3 divided by 4, and both are integers. 3 divided by 4, the actual value is 0.75, but when you divide integer by integer, it only gives you integer part of the answer, which is 0. So 0 multiplied by 3 will be 0, so S has a 0 in it. Integer value 0 in it. Going to J equal to 3.0 over 9. 3.0 is a float type number. Divided by 9 will be 1/3, and that will be 0.333. And you're multiplying it by 3. So when you multiply it by 3, the product is a float type number 1.0. So 1.0, or simply 1 point, will be the correct answer. If you wrote 1, I didn't penalize you. I gave you the credit this time, but when the answer is a floating point type, you should have that decimal point in it. Looking at K, A plus 2.0 divided by 2.0 divided by B plus 2. So the division will be done first. 2.0 divided by 2. So that 2.0 divided by 2 will be 1.0, floating point number. You're adding that to A. A is also floating point number. So the result of that addition is 2.0. That's a division, sorry. You're dividing by 2. Okay, so that will be a 2.0, and you're now dividing it by 2, and the result is 1.0. So again, the decimal point should be included in the answer. So value of S is 0, value of J is 1.0, value of K is 1.0. That will be the correct answer. If you miss the decimal points, I didn't penalize you, but I would be penalizing you in future exams, future homework and test everywhere. Decimal point cannot be missed. All right, anything else we should go over? Okay, then I'll just move on to section 2.5, variable types and memory allocations. Now, in the assignment, I reminded you in my message that you're supposed to, in the project that is, you're supposed to round your answers to the nearest 100th. That was one of the corrections made to your book. And if anybody missed it, if you didn't do the rounding, I'm going to allow you to submit improved version with the rounding by 5 p.m. today by email. Just send me a replacement, I'll replace it for you. I'm just giving you this chance because this is the first time correction is being actually implemented. The correction made in the document called corrections in the book. If you haven't done those corrections in the book that was posted on Blackboard, you're supposed to do those changes in your book by handwriting them. And if you haven't done it, please do that soon, because in the future, I will not give you a second chance to improve the assignment. So if you do a wrong problem, you end up getting no credit for it. So please make those changes now. So others, if you didn't do the just that part of rounding, then I will accept a improved version by 5 p.m. today by email. I'll replace it for you. You just send it to me by email. Okay, so let's do the 2.5 variables and memory allocations. We already learned what's the memory, how much memory will be allocated for the basic data types, int, float, and char. But we're going to learn some more data types today, and we will learn how the memory will be allocated, what kind of memory will be allocated for them. And then, so basically some fine details will be done in this section, 2.5, and that'll be the end of chapter 2. All right, moving on to the data types. You already learned that the variable char, if you declare a variable as char, you'll get 1 byte of memory, because the char type is basically for storing a character, and every character is coded with 8 bits, and therefore 1 byte of memory is enough, so it'll allocate 1 byte of memory for that. If you declare a variable as int type, you'll get 4 bytes for it. Float type will also get 4 byte. So between int and float type, float is considered to be larger, even though the memory allocation is same. These are things we learned before. All right, warm-up exercise. What is the largest positive integer that can be stored in a char type variable? Now, you know that char type variable can hold integer. You can store integer in char type variable and get it out as integer as well. What is the largest number that can be stored in a char type? Let's go over that quickly. You did this before, but let me explain again. So it'll be the largest number that fits in here will have all 8 ones. 1 second, one error. Okay, so the largest number that fits in here will have all 8 ones. So the number has 8 ones, and that means we need to convert it to an integer. To answer the question, I have to convert to decimal form. So the last one corresponds to 1 times 2 to the 0, and 2 to the 1, all the way to 2 to the power 7. The 8th bit corresponds to 2 to the 7, because the exponents start at 0. And we learned the formula that 1 plus, or 2 to the 0 plus 2 to the 1, all the way to 2 to the n, is equal to 2 to the n plus 1 minus 1. You have to remember this formula to be able to calculate these. So this sum of 2 to the 0 to 2 to the 7 is equal to 2 to the 8 minus 1. And 2 to the 8 is 256. So therefore, largest number that fits in 1 byte is 255. The char type variable, which is 1 byte memory, 255. So if your number is smaller than 255, you can use the char type variable to store it instead of int type. Numbers can be stored in char type. Okay, so there are other data types allowed in C++ language. The purpose of having other data types is to request a different amount of memory. Instead of 4 bytes for int, I can ask for 2 bytes or 8 bytes, depending on how big my numbers are. So therefore, here are the other data types. The short int, if you declare a variable as short int, or simply short, you can use the word short instead, then you will get 2 bytes of memory allocated. So it is designed for integer numbers, but you're getting smaller memory, 2 bytes. So char type variable can be always used to store numbers, and you get 1 byte. If you declare short type, you get 2 bytes. Int will get 4. There's also long int that will give you 8 bytes, but 8 bytes will be given only in larger computers. Since a microcomputer has limited memory, any program you execute on a microcomputer will only allocate 4 bytes. But it's there, if you need 8 bytes, you just have to use a larger computer. Float gets 4 bytes, as we discussed before. There is a double type. Double is designed, basically double float. In other words, you're getting twice the memory as float, 8 bytes. And so that's useful if your numbers are very big or you need very good accuracy, because if you use double type, more fractional digits will be carried over in your calculations. So the answer will be more accurate. There is still long double, which will be good, which will get 16 bytes in larger computers. In microcomputers, you only get 8. So in microcomputers, long end and long double are not useful. So we'll stick with only the other ones in microcomputers. Char, short, and int, and then float and double are still good in microcomputers. So you have to basically decide how big of memory you need, because if all your numbers are very small, there is no need to use int or long int. You may want to use just char and short int so that you minimize the amount of memory you're using. Some questions in your homework will ask you to use a minimum memory to do a program. So let's go over some of those things. For example, suppose that we need a program to add two numbers, 365 and 132. And we just went over the details of what is the largest number that fits in 1 byte, and that's 255. So 365 doesn't fit in 1 byte. So if I'm writing a program to use minimum memory, the 132 can go in a char type variable. So 365 needs 2 bytes at least. So you can declare short. So I can write the program this way: short int num1 equal to 365. And for the answer also, I'm declaring short int type. Then char type num2 for storing 132. Because 132 is smaller than 255. And then sum equal to that and print the sum. Okay, so that seems like the right program. But there is one little detail we need to pay attention to. That is, there's nothing wrong with this program, it's correct. But num1 is short int, num2 is char. So remember, in any operation, if the two operands are matching type, then the answer will be of the same type. If they're not matching type, then they both will be converted to the larger type. So which is the larger type among these? Num1 is short, num2 is char. Which is larger type?
The short int.
Short int is larger.
Num1.
Num1.
So the num1 has to be the larger. Num1 is larger type. So the num2 will have to be converted to short int as well. Remember, both have to match. So it'll convert both of them to the larger type.
Hello.
So the question, I'm sorry. Okay, so num2 will be converted to what type? To short type, right? So that means right here, before carrying out this operation, num2 was stored in a one byte memory. Now it has to be converted to 2 byte memory right here before the operation. So that means what? Essentially, the char num2 here, we stored in 1 byte, but we're changing it to 2 byte right here. So there's no point in using the char here. That's the point I'm making. So since we are converting it to 2 bytes before the operation, we may as well declare that original declaration as a short int. We could have just done short int. There's no benefit in using char. So if the other number is going to be short int, this number being char is not helpful. They're going to be both converted to short int. So therefore, just declare them all as short int. Of course, we don't need to use int. So to answer the question, short int is the best. We don't need the char. That's what I'm saying. Even though this program is not wrong, you're not benefiting from the declaration of the char type. So it's better to just declare all of them as short type and write the program this way. Short int num1 equal to 365, num2 equal to 132, and sum. All of them short int type, and then sum equal to the addition of those, and then print the sum. there's no point in declaring different variables as different type. Just use same type. If you have any operation in the program like this addition here, then declare them all as same type. That's the point of that discussion. All right, moving on to sign bit. Sign bit of a memory. When you, in the past, we didn't talk about negative numbers, but it's time to talk about them. In programming, we have to deal with negative numbers as well. So when you're storing a number in a variable, what if the number is negative, what happens? The negative number will be put through some kind of process by the compiler to come up with a binary code, which is not exactly the binary code of the number and a negative sign. It's something else. So that process, I don't want to get into that explanation now, because that's something you will be learning in advanced computer science. You know, when you learn more about the machine language, detailed machine language, you'll be learning those details. So I just remember this way, you know, there is one bit reserved for the sign whenever number is allowed to be negative. So when you're allowing negative numbers, you're going to allow one bit to be reserved for the sign, and therefore only the remaining bits are available for storing the number. So in the past, we discussed only in terms of bytes and bits, didn't discuss things in terms of variable types. So earlier, one of my statement was, if you allocate 2 bytes of memory for a number, then the largest number that can fit in that 2 byte of memory is 65,535. Let me go over that one more time here. If you allocate 2 bytes of memory, then you have 2 bytes. So here is 2 bytes. The last 8 bits will go in the latter byte. So all of them will be ones there. And then the previous one, the largest number that fits in these, will have another 4 ones and another. So all this is the largest number that fits in 2 bytes of memory. And if you convert that, that's if you allow just positive numbers, then this will be 2 to the 0 plus 2 to the 1 all the way to 2 to the power. This is 32nd bit will be corresponding to 2 to the 31. So the sum of these is the largest number that fits into the memory, and apply the formula, it'll be 2 to the, that's 31. So 2 to the 32 minus 1, and 2 to the 32 minus 1 is 65,535. And so that's why we said largest number that fits in 2 bytes is 65,535. But now, at that time, we didn't talk about the numbers and negative numbers and all that. So now we are just learning that if you are allowing negative numbers, then one of the bit will be declared, one of the bit will be allocated for the sign. So when you declare the variable as short type, you are allowing negative number. So if I declare the variable as, remember, short int and short are same. I can just say short x. Okay, then x will be getting 2 bytes, but now we are allowing sign. So therefore, the one bit will be used for the sign, and therefore you don't have 32 bits available. You only have 31 bits available. So if I declare the variable as short x, then what is the largest number that can fit in here? So let's compute that. Let me clear the board. So what I'm going over right now is largest number that fits in short type x. If I declare the variable as short x. Okay, so here's how the calculation goes. 2 bytes are there, but only the second byte will have all ones, 8 ones. The first byte will have only 7 ones, because the other bit is sign bit, only 7 ones. So therefore, the corresponding decimal number will be 2 to the 0 plus 2 to the 1 all the way to 2 to the power 30, 30, not 31. This is 31st bit. 31st bit will correspond to 2 to the 30. And so if you simplify that, it'll be 2 to the 31 minus 1. And 2 to the 31, I'm going to calculate in my calculator. 2 to the power 31 equal to, I'm sorry, what am I doing here? The 31 is wrong. This is 16 bits, so this is 15. This is 15th bit, right? Not 32. I'm working with 4 bytes instead. In 2 bytes, you have 15 bits, and because 16th bit will be signed bit. There are 15 bits, so it'll be 2 to the power 14, which is equal to 2 to the 15 minus 1. Okay, so 2 to the 15 minus 1 is what I need to calculate. 2 to the power 15, 32,768. 32,768. If I subtract the 1, it'll be 32,767. So this is the largest number that fits in short type variable. Because we are allowing negative numbers. So the numbers can be negative now. So what is the smallest number that fits in the short X? Negative 32,767. So the range of numbers that fits in short type would be negative 32,000 to 32,767. So that's what you need to remember. Well, you don't have to memorize it, but you have to be able to calculate that. So short type variable allows negative number, and therefore the range of numbers that can fit in short type would be negative 32,000 to positive 32,000. Okay, so if you allow negative sign, then this is the limit. So what if I don't want the negative sign to be stored? Can I ask for that? Can I say I don't need the sign bit? Yes, actually you can. So that's called unsigned data type. So if I don't need the sign to be stored, I know that all my numbers are positive. I don't need to deal with negative. Like, business problems. All your numbers are prices of things. Prices of things are positive numbers. So why do I have to deal with the negative? Deal with the memory that allows negative. So you can just say, you can just ask for unsigned data type. So instead of short int, simply short, I can say unsigned short, like this. Unsigned short int. By the way, I can exclude the word int, still it'll be correct. Unsigned short is same as unsigned short int. So unsigned short val, if I declare that, then there will be, all 16 bits will be available for storing the number. So that's when the largest number that fits in here will be 65,535. So as you can see, if you allow the sign bit, then the number goes down to about half, and 32,767. But then you're allowing negative numbers. Okay, so in summary, if you declare the variable as unsigned short, then the largest number that fits in that memory is 65,535. If you don't say unsigned, if you declare as short variable, then the largest number that fits in there will be 32,000 instead. Always feel free to ask question if you have any. Okay, moving to largest numbers that fit in variables. I just explained that already. So unsigned short type for 65,535 is the largest number. If it is just short type, then 32,000 is the largest number. Let's look at int types. If I declare a variable as int, then I'm allowing sign. If I declare it as unsigned int, then I'm not allowing sign. So the difference is 1 bit. So if I declare it as int x, then all 4 bytes are available for the number. All 32 bits are available. So the largest number that fits in there will be all ones. I'm sorry, if I declare it as int x, then there are 4 bytes, but 1 bit is reserved for sign. So therefore, this first byte has only 7 bits available for the number. So the largest number that fits in here is going to be in decimal form, 2 to the 0 plus 2 to the 1 plus all the way to, this is 32nd, this is 31st bit. So 2 to the 30. And the sum of these is equal to 2 to the 31 minus 1. And 2 to the 31, if you calculate in your calculator, two to the power 31. 2,147,483, 648 minus 1 is 647. So this is the largest number, almost half of the other number. What is the largest number that fits in 4 bytes? If you declare it as unsigned, so if you declare it as unsigned int x, then you have all 4 bytes available, and the largest number that fits in there will have all ones. Now there's no sign bit anymore, so they're all ones. So it goes from 2 to the 0 to 2 to the 31, and the sum is equal to 2 to the 32 minus 1, and 32 to the 32 is 4 billion. Let me give you the exact number. For this particular answer, the book has the wrong number. I corrected it in the corrections. The corrections in the book document has the correction made. So let me give you the correct number. 2 to the power 32. So if you subtract, after subtracting 1 is 4,294,967,295. So that's the largest number. So as you can see, this number is almost half of that. But here, negative numbers are allowed. So the smallest number that fits in int x would be negative 2 billion. The largest number is positive 2 billion. In unsigned int x, shortest number is 0, and largest number is this in unsigned short int. Unsigned int, that is. Sorry. Okay, so you just have to be able to calculate those. You don't have to memorize these answers, but if the problem says compute it, you have to be able to compute that. Some of the homework problems will ask you for that. Okay, moving on. Let's look at an example. It says write a program that uses minimum amount of memory to multiply the numbers 345 and 452. Okay, 345 and 452 are small numbers, but they don't fit in char type. Char type can only hold 255 the most. So we have to use unsigned short. So I'm going to use unsigned short and declare 2 variables as unsigned short. And answer is going to be stored in val, and that's also unsigned short. And then I say val equal to k times m and see out val. Okay, so the program looks to be right, and you don't notice any problem just by looking at it. But there's a serious problem here. this program is not going to work. Anybody see the problem? Anybody recognize what it is that's wrong here? Okay, yeah, it's not straightforward. It's a hidden problem. So let me explain. If you multiply the K, 345 is K, and M is 452. And if you multiply that, 345 by 452, the answer is 155,940. 155,940. 155,940. So now you see the problem?
The answer is not a short
And
type
it's not
variable.
going to fit in short type, exactly. The answer is the largest number that can fit in unsigned short is 65,535. But our answer is 155,940. So it's not going to fit in short type. And that's what we call overflow. Overflow error. Overflow is, in some other languages, overflow is an error. It'll give you an error message. But in C++ language, it's not going to be an error. C++ compiler will not report this as an error because in C++ programming, this overflow is sometimes used as a technique to extract some bits from a number. So to extract bits from a number, overflow is sometimes used, and therefore it will not be reported as an error. So what will happen? The actual number we have here has more than 16 bits. That's the problem. So when it has more than 16 bits, it will just store the bits it can store in the 2 bytes, and there will be some other bits that will not be stored. So the stored bits will represent certain number, and that number will be produced as answer. So these dropped bits are gone. So when you drop bits, your number is going to be wrong, right? It's going to be wrong answer. And also, if the first bit happens to be a 1 after you drop those bits, then the number will be reported as negative because that's how the sign bit works. If the sign bit has a 1, then number is negative. If it is 0, it's positive. So the number can even come up negative, which is the wrong answer. So that's the problem. If this is a homework question, if it says, here's the program and write the output, your answer has to be wrong answer, or wrong results will be produced. That's the answer. If you write this 155,940 as the answer, that's the wrong answer because that's not going to fit in that memory, so it's not going to be reported as the answer. So anyway, the point is then this program is going to run without an error message and it will produce wrong answer. The programmer has to pay attention to these details and make sure the right answer will come out of this by declaring the variables as appropriately. So here, the problem is the short type memory is too small for the answer to fit. So what should I change here? What is the remedy to make it work right? What changes should I make in this program? Anybody? You need to unmute yourself if you're talking. Anybody has an answer?
Do you just change the declaration?
Declaration to?
I'm not sure.
Int. The only larger type than short int is int, right? So we had to go larger. The short int memory is not good enough. So declare it as int or even unsigned int. Unsigned int or int will be correct answer. So the problem if the question says, what is the problem? Why is this going to produce wrong answer? Then you have to explain. The answer doesn't fit in short type. Then what is the remedy? You change the declaration to int instead of unsigned short. Int or unsigned int, both are correct. All right, moving on. So let's look at another program. Int k equal to 6345 and val is also int. Unsigned short int m equal to 21. And then val equal to k times m. Okay, so this time the answer will be coming out right, even if the number is, there's no problem about overflow here because val is declared as int and also k is declared as int. So k is int means m will be also converted to int and the answer produced by this product will be int. So answer will fit in int type. So there's no problem. So this program will work. Only thing I wanted to mention was the unsigned short declaration here didn't really help because that unsigned short variable is getting converted to int right here in this operation. Before carrying out this operation, it's being converted. So you stored it in 2-byte memory, but it's getting 4-byte right here. So therefore, this declaration is just a waste of effort. You could have just declared m as int type instead. That's the only thing. But the program is not wrong. Everything is fine. That declaration didn't really help. Declaration of short type didn't help. Okay, moving to the next example. Let's look at this program. Unsigned short type equal, this is the same question. I already explained that. The problem with this is everything will work and it will produce an answer. The answer will be wrong because this C equal to A times B right here, this product is not going to fit in the short type answer. So declaring C as, even if you declare C as int, it wouldn't still be okay because this product right here is going to produce a short type answer. But the actual answer doesn't fit in short type variable. So this product itself is the problem. So the A and B both being short is the problem. The answer will be short type, but answer cannot fit in short type. So therefore, it's a problem. Now remember, declaring C as int is not going to help. A or B has to be int or both needs to be int. Only then the answer will be right. So I actually ran this program. The correct answer is 105,750 and the actual answer produced was this negative number. It was negative number because it just stored the bits that can be stored in the 16 bits and the first bit happens to be a 1. So it's recognized as a negative number. So it's a completely wrong answer that you get. So the reason you understood already. And the remedy is to change this declaration to unsigned int or int. One of those two will work. Okay, so now we have learned so many different data types. Let's look at the hierarchy to see what is larger than what. So some of these data types are larger than the other, and we need to know them because in any operation, if there are two different types, if the operands are of two different types, they both will be converted to larger type. So we need to know which is larger type. And long double is the largest type. Double is next smaller, float is smaller. Now, obviously, because float gets 4 bytes, double gets 8 bytes, long double gets 16 bytes. So, the bytes are bigger. You can just look at the size of the memory to compare that. So the unsigned long int, even though this has only 8 bytes, this has 8 bytes allocated, where float has only 4 bytes allocated. Still, float is considered to be bigger type than unsigned long int. I explained before already that always the fractional number, the memory for fractional number, is considered to be larger. So all float types, float, double, long double, these are all larger than largest integer type. And then unsigned int is the next smaller one. Int is the next smaller one. Now you can see the reason why unsigned int is bigger. It's bigger by 1 bit. Int has 1 fewer bits for the number. Unsigned short is the next one, and short. And then the bottom line is char. I didn't write the char there by mistake, but char will be the smallest. So these are the data types. If they are mixed in an expression, then they will be converted according to the size. And the result will be of the larger type. And therefore, you need to know what conversion will be happening. And for that reason, remembering this will be helpful, but there's nothing much to remember. They're all based on the size. Only thing unusual here is the float has 4 bytes, unsigned long gates get 8 bytes, but still float is bigger. That's the only thing to remember. Everything else is very logical. Okay, moving to our warm-up exercise. All right, normally this will be done in class, but we can do it differently now. It says write a program to multiply the numbers 380 and 200 using minimum amount of memory. So my question is, what should be the data type for the variables where I store these values?
For the first one is int.
Okay, there's I already explained that there's no benefit in mixing the data types. Declaring one of them as int and the other one as short is not going to be beneficial. They're going to be converted to a larger type during the operation. You're going to be multiplying them. So we can just use same type for both of them. So what is your suggestion for the data types? Can we use short for both?
No,
Yes.
No. What's the problem?
because 380 is bigger than 270 than 255.
255 is the largest number that fits in 1 byte. So that'll be char type. Only if I declare a char type, I get 1 byte, and 380 doesn't fit in that. That's right. But 380 fits in 2 bytes, which is what I get for short.
Can we use unassigned short?
Unsigned short. Okay. So can we use unsigned short for both variables and write the program to multiply them? Is that correct? Do you all agree? Anybody with a different answer?
Would it have to be int because when you multiply them, it comes out to 76,000?
Exactly. That's very good. Excellent. You got the answer. That unsigned short is not going to work because the product is too big to fit in short type. The product is 76,000. It doesn't fit in unsigned short or even short. So we have to use int. That's the only way. So you have to declare them as int x equal to 380, y equal to 200. No point in mixing two data types. So make them all int type, and then z equal to x times y. This is the only way. So problem says write the program to use minimum memory, and the minimum we can use is 4 bytes. That's clear. So that's how you write that, int or unsigned int. Either one will be correct. Okay, for the next question, write program to multiply the numbers 55 and 20. 55 and 20 both fit in 1 byte of memory, right? But if you multiply them, we are multiplying them. And
Professor, really quickly, I have a quick question. For the test on Monday, March 8th, is it in class test or is it going to be like through Blackboard?
it'll be on Blackboard, but you had to take it in a class meeting.
Gotcha.
All
Thank
right. Yeah. We'll be discussing a little more about test in a few minutes. So 55 multiplied by 20 will be 1100. So clearly we cannot use char, right? The product doesn't fit in char. So what should I be using? What data type?
Short.
Short.
Right, and we can use unsigned short because they're both positive numbers. So unsigned short type variables, all three variables should be unsigned short, and that'll do it. So remember, if this question is a homework question, write a program to multiply these numbers using minimum amount of memory, then only if you use unsigned short or short, the answer is marked right. If you use int, then it's wrong answer because you're not using minimum memory. Okay, even though a program will work, you're not answering the question correctly. So it'll be a wrong answer, whether it's in the homework, test, everywhere. Okay. There is one more thing I need. So that finishes our section, but I need to explain one more problem, how to do that kind of problem. So let me go over that. If you have a question that says, there are questions like this in homework, and it may come up in the test also. So that's why I'm explaining. I can declare a chart type variable called X and store 97, and then declare another chart type variable Y. And then I can say Y equal to X plus 3, semicolon, and then see out Y. And then the question may ask you to write the output of this. All right, let's go over that detail. The 97 will be converted to character because X is character type. And so you had to use the character conversions. If you remember, you don't really have to memorize this. This information you can always look up. 95 corresponds to lowercase a. So 96 is lowercase b, all the way to 122 will be the lowercase z. So this information will be given to you if it is test question, but that's what you had to use. So 97 will be C, right? 97 corresponds to C. Okay, so this 97 will be converted to C, so X will have a C in it, the character C in it. And then you're adding, here you're adding 3 to the C. Is that valid? Yes, of course, you know, in an operation, the two operands can be of different type. They will be converted to the same type. So 3 is recognized as int type, and therefore the X will be converted to int type, and that will be 97 again, right? So that'll be 97. You're adding 97 and 3 now. And that's equal to 100. And then you're storing the result in Y, but Y is char type. So therefore 100 will be converted to character. So when you convert 100 to character, that'll be 98 is D, 99 is E, and so 100 is F. So therefore Y has F in it. There's F in there, and see out Y will print F. So the output is F. That's your answer. So remember, there's nothing invalid about this program. You're storing a number in a chart type variable, it will be converted. Then when you're doing addition, conversion happens again. And then when you're storing the result in Y, conversion happens again. It will be converted to character. And then printing character, because Y is character type. If I want to print an integer instead of character F, I can do that. My cout statement has to be cout int Y. Then the output will be 100 if I do that. So these conversions are valid. There's nothing wrong with them. I just wanted to point out this because there are problems like this in the homework and you should be able to do that. So that basically finishes our discussion of chapters 1 and 2. There will be chapter 2. This 2.5 homework will be collected, will be you have to submit it before the next class. I'll have the link ready today, later today. Oh, and so in the next class, homework number 6 and homework number 7, we will discuss both. Even though the 7 will not be graded by then, we'll have to go over that because of the test. Test is in the following class. So the test will be in a class meeting, just like this class. You will meet, and so while you are in the meeting, you will be taking the test on Blackboard. The test will become available only at the time you're allowed to start, and then it will end at the time it's supposed to end. At the ending time, it will automatically submit itself and it will terminate, and you won't be able to do any more of the questions. Also, in the past, I allowed everybody to be able to go back and forth, like in the paper test, you're able to turn pages and go back to a previous problem and work on that. I used to allow that, but in the last semester, there were several students who cheated on the exam. Because I allowed that, they were communicating. They started to communicate and passed answers back and forth. But they couldn't fool me. I was able to figure that out by looking at their answers, the solutions. And there were 6 students given failing grade because of that cheating. I felt sorry about that. 6 is a big number. In the past, when we had tests in the classrooms, I never had cheating occurring because, in classrooms, it's very hard to pass information to each other. Phone was not allowed. And now, even though phone is not allowed, they were able to use it without me noticing it. And so that's how they cheated. So for that reason, in addition to not allowing any communication device or any software, none of that is allowed. While you're taking tests, you're only supposed to be doing the test on the Blackboard. Absolutely nothing else is allowed. And even with that, I can't seem to be able to control it. And some students managed to cheat and ended up failing. So to minimize that, I have to now allow you to only do one problem at a time. So after doing a problem, you move on to the next and you won't be able to go back to the previous one. I had to do that to minimize cheating, unfortunately. So that's the only thing, different from paper tests. You finish a problem and move on, then you won't be able to go back to it. The other thing I want to tell you is to prepare for the test, what you need to do is go over all of the homework. There are 7, 8, this new one, no, 7. You have one more to turn in before next class. So that makes it 7. Go over all 7 of them. You have access to them on the Blackboard. Go back to them and make sure whenever you got something wrong, using my comments, you can understand what went wrong. Otherwise, you can bring up the question for discussion in the next class. Next class is going to be entirely discussion and review for the test. So in addition to going over the homework, after you do going over the homework, you need to do the review. The review is posted on Blackboard in the supplement section, and print it out and do all those problems. The answers are there, but don't just read the answers. Do them without looking at the answers, and then compare the answers to see whether you have done it right or not. And then you learn from the mistakes, learn to do it right. Then you'll be prepared for the test. And any question you are not sure about, you want explanation on, bring up to the discussion. So next class is going to be entirely discussion of homework 6, homework 7, and the review questions. We will discuss all those to get ready for the exam. So if you prepare, if you do go over the homework before next class, then you'll have a chance to ask questions on the homework, on all of the homework.
The
Yeah.
exam, how many questions will it be?
In the exam, there will be 50 questions, but that counts even the elementary questions, such as what is a computer, what is a computer program, you know, things like that.
Will those be multiple choice or you have to write those out?
Mixed. Mostly you write the answer for the question. And for example, if I'm asking what is a computer program, then there'll be blanks to fill out. A computer program is this, you know, a blank. So filling out the blanks and answering question with numbers, also sometimes multiple choice. So they're all mixed. But so some questions will be auto graded by the system, but I will be going over the whole thing because the machine grading is not always accurate. So I'll be actually manually grading all of them afterwards.
And the test is as long as a class?
Yes, the test is designed to be designed to take only about an hour, but you have hour and 15 minutes class time. But I'll give you extra time up to 15 minutes if you have it. And so basically it'll go on to about 1.5 hours. No, 1 hour and 45 minutes is the maximum time allowed. And only after that, the test will shut down. So if you have the time, I'll give you some extra time.
Another question. During the exam, will we be writing like programs like in the middle, like for some of the
No,
questions?
you won't be running programs. You'll be writing programs just like you write them.
Yeah, that's what I mean.
Right. There will be programming questions. There are 3 programming questions to write complete programs. Complete programs you will write by beginning at the main. You don't write the pound include and all those things before the program. You don't write comments, none of that. Just begin with the main and write the body of the program. There will be about 3 questions of writing program, and others will be just questions and answers, multiple choice and things like that. There will be, of course, converting numbers to binary or converting from binary to decimal, converting number from decimal to octal, converting back octal to decimal, all those things you did in your homework, you'll be doing them in the test also. So they're not multiple choice. For those questions, you have to write the answer. You do the work and write the answer. You don't have to show the work, but you just enter the answer. And the question numbers will be changed for each student. That is also to minimize cheating. You know, if you ask somebody to give you your answer for number 5, his number 5 and your number 5 will be different. So those are to avoid or minimize cheating. Any other question? So the test will be like class. You know, you'll be all meeting in the Zoom meeting. But I forgot one important point. Now you have been, you know, in classes, you know, you have been logging in or joining the meeting, but you had the videos turned off and audio turned off. But in the test, you had to have videos turned on. I have to see you. I had to see who is taking the exam, and I had to see exactly what you're doing. And you should be just working with the computer and nothing else. So I had to be able to see that. So your video has to be on. So if you have some problem with your video on your computer, then you're not allowed to take the exam. So you need to make sure your computer video works. Okay, I have to be able to see you. And so if you need to, you can borrow a computer if your computer has problems with the camera. You had to sort out that problem and make sure your video can be turned on and I can see you doing the exam. So if anybody is taking the exam without the video, that student's exam will not be graded. No grade will be given. It'll be 0. It won't count. So remember that. And any problem with your computer camera should be solved before that next class, before the exam, which is Monday. Next class will be all discussion, answering questions on your homeworks and review questions and things like that. That's all we'll be doing next class. All right, any other question?
Quick question. I just wanted to make sure, because I know this is probably going to go through Turnitin. As far as the definitions go, that won't be like flagged as plagiarism if we use like the textbook definition and we have it memorized, right?
No. Of course, some of you may have the definition memorized and write exactly as it is in the book. That won't be considered to be pleasure cheating. Okay, that's fine. Yeah. The cheating is very visible in the programs. That's where students easily get caught. They don't realize it. They even think that they can change the variable names. Of course, the variable names are supposed to be your choice, right? So that's what they do. Students, they take somebody else's program and change the variable names and think that they get away with that, but they don't. The program structure will be different from written. If you write your own, it'll be different from others. Okay. Any instructor in this field has enough knowledge to be able to see when cheating has occurred. Those 6 students I was referring to, I was able to see that they cheated by looking at their program. And after I filed the report to the vice president, when they analyzed, they actually had other computer science professors look at it to see if they agree with me. They agreed with me because any computer science professor can easily see when the program is duplicated, even if they change the variables. So they agreed with me, and the students were punished by the vice president's office also. So, in addition to my punishment is failing grade immediately. And then it will be reported to the vice president's office, and they take further actions. So cheating is considered to be a serious offense, and so please don't do that. We can figure out who cheated in what. Last semester, I failed 1 student for cheating on the assignment. Cheating in the assignment is forgiven one time. I give you just 0 credit, and I don't punish you in any other way if it occurs only one time. If it occurs second time, then you fail the course. So that happened for 1 student last semester. And so again, you should remember, I'm actually comparing your work, and not only me, but the Turnitin system also compares your work, and it reports to me when 2 assignments are similar. I can see that myself, but Turnitin is a smart system, and it also compares your work, and it has a comparison report for all your assignments. So usually Turnitin system tells me 60% match. These 2 are 60% match. That's normal. 60% match is normal. But when it says 90%, that's when I have to worry about it. All right, go ahead.
For Turnitin, is it possible that you can set up a way we can put comments on our assignments, just in case we go back to it later in the day and see something you want to change, to just instead of
I didn't exactly get that. But you submit the assignment, and you're saying you want to write comments on top of that?
Because on Blackboard you're able to write comments on your assignments, but since we're using Turnitin,
on Blackboard, I'm not following you. When you're writing the assignment, you can write any comment you want to write on the assignment. Why do you want to write something else after submission?
never mind.
Sorry. I didn't really follow you, but if you, yeah, Turnitin system doesn't allow you to do anything after you submit. It doesn't allow you to modify or submit another one or write anything else on top of it. It only allows me to write things on the assignments. That's how it works. So if you need to resubmit, you submitted something and you realize something wrong, you want to resubmit that. If it is, if the due date is still, sorry about that. Okay, if the due date is not met yet, then you're allowed to resubmit. You just have to ask me to remove the old one so that you can submit a new one. But if the due date is up, then you won't be allowed to resubmit. All right, anything else? Okay, so then,
Yeah, can you bring up that formula again? The one that you used to find how many bits are in
the largest number that fits in.
yeah, the n-1 formula.
Okay, yeah, I can do that. It's in your book and it's in that lecture video. You can review the video if you like, but I'll write it down. The largest, to find the largest number that fits in any memory cell, you'll have to use the formula for the series 2 to the 0 plus 2 to the 1 plus 2 to the 2 all the way to 2 to the n is equal to 2 to the power n plus 1 minus 1. This formula you need to remember and use that to figure out the largest number that fits in memory. So the questions in the test that ask you about largest number that fits in memory can be this way. It can be like this. A variable is declared as short x. What is the largest number that fits in here? That would be 32,000 something, right? The correct value. But another question can say variable is declared as unsigned short x. Now what's the largest number that fits in here? That would be 65,535. You're actually expected to calculate, but if you try to memorize these numbers, you can mix them up. You can get it wrong by mixing them up. So don't try to memorize. Immediately calculate and then write that answer. You're not expected to show the work. You're only expected to enter the answer. So you can enter the answer. If you have it memorized, yeah, you may end up, you can end up memorizing and entering the answers. But there are so many of them that if you memorize them, you can end up getting and numbers mixed up. And instead of even asking these questions this way, I can ask a question, here's the variable that's going to be allocated 5 bytes of memory and calculate the largest number that can fit. So don't rely on memorizing, rely on calculating it yourself, okay? You had to be ready for any question. All right, any other question? All right, then we'll close here. Now remember, next class will be entirely discussion, preparing for the exam. So bring up all your questions for discussion, including the review questions. All right, enjoy the rest of the day. I'll see you Wednesday.
Have a good one.
You too. Bye-bye.
Professor.
You too.
Bye, Professor.
Professor?
Yep.
I think you marked me late today. I was having trouble logging in and I was actually in the waiting room. And I had sent you an email after like 5 minutes because I thought it was a problem, but
Okay, what's your name?
Ariel Romero.
Yes, I did mark you in late. So you were saying you were here from the beginning, you just had trouble logging in.
Yeah, I was in the waiting room. It was telling me the host was supposed to let me in.
Yes, I am supposed to let you in, and there is somebody waiting now. So you're supposed to, I'm supposed to let you in, but whenever I see somebody waiting, I let you in. And I saw you only at 9:40.
Hi, Professor.
Yeah.
I went to the bathroom, but I was like in the thing. I pressed on your link, but then when I came back, I didn't realize I had to like confirm whether I had my video on or not. So I got let in. I think I got marked late because of that, but I came in like at 9:27, I believe.
You are.
Yeah, Professor, I also have the same issue.
I went away for like a minute and I didn't know like I had to like be like let it like confirm something before I come in.
Okay. You are Benjamin Chen, right?
Yes.
Okay. I did mark you late and you're saying you were not. Okay, so I'll mark it on time.
Yeah,
Romero,
Professor, also me as well.
okay, you were having trouble logging in. This is Romero, right?
Yeah, I was having trouble.
Who's the other one? The third,
Yeah, also Gabriel Charias.
Charis.
Yes.
Okay. What's the problem you had, Charis?
The same issue that I just didn't click the confirm to put video or not. So I got in at like 9:26 or 9:25. Like I just missed it.
Okay. All right. I'll mark you in time. Romero also on time.
All right, thank you, Professor.
You're welcome. Have a nice day.
Oh, and I actually have one more question.
Yeah.
Since we can't submit the homework after the past due date, I was just wondering, like, if you could give us the answers after the due date, so that way we could compare, like, um, you know, to see like what we did wrong. That's okay.
You mean place the correct answers after the due date?
Yeah, the solutions for the questions.
I could, but I always write my comments as to what is wrong in your homework. If I want to place the correct solutions, it has to be somewhere in the blackboard, not on the Turnitin system. I can't post anything there. I can't post anything that you can see. So why don't we try just a discussion? Now, we are going to discuss the homework in the next class, homework 6 and 7.
All right, that works then.
Yeah, so that should work. The reason why I don't like to present the solutions is it doesn't help. It doesn't work. Somebody has to tell you why the solution is that. Okay, just reading the solution doesn't work in this course.
All right, I understand, Professor.
Yeah.
Thank you.
Yeah. So we'll discuss in the next class.
All right, take care.
You too. Bye bye.